Okay. In section 3-1, we're on the back side of our notes. There are ways of classifying systems of linear equations. Okay. So please refresh my memory from yesterday. What is a system of linear equations?
Lines.
Okay, we're talking about lines. That's what linear would mean.
That's the two lines that intersect with two equations.
Okay, well, you have two equations. So a system is two or more, right? Two or more equations. A system of equations is two or more equations that we're trying to solve together. Okay, we're trying to find the answer to all of them at once. And since we're dealing with linear equations, of course, we are then talking about two or more equations of lines. So we can classify a system of linear equations as being consistent, independent, consistent, dependent, or inconsistent. Okay? It's a way of classifying these, and it also happens to tell us what type of solutions we're going to end up with. You guys saw one in your homework yesterday that had no solution. Why did that system have no solution? They never intersected. Well, think back to geometry for a moment. What type of lines don't intersect? Parallel lines. That was the issue, is that we had parallel lines, therefore they never intersected, and so we had no solution. So if you have parallel lines, they are considered an inconsistent system. Okay? That's going to be part of your homework today, is identify what type of system you're dealing with without graphing. So how would I be able to tell without graphing? Look at the slope, right? If the slopes are parallel, how do I know if lines have parallel slope? Same slope, right? The exact same slope. So if the slope is the same, that means they're parallel lines. That means it is an inconsistent system, which means it'll have no solution. Okay? Well, then the other two, if we have solutions, because that right there is the big distinction between the two. If you have solutions, it's consistent. If you have no solutions, it's inconsistent. Okay? So if you have solutions, it's consistent. If you don't have solutions, it's inconsistent. Well, between the consistent, we have independent and dependent. We have two subgroups. Okay? Independent and dependent. Now, a consistent, independent system means that you have one solution. You have one solution, and the two lines then have different slopes, right? There are two different lines they cross at one point. Again, think back to geometry. If two lines intersect, they intersect at exactly one point. Okay? So a consistent system means you have solutions because it's consistent. And if it's independent, that means the first line is independent of the second line. They're going to cross and get one solution. The other option is that you have a consistent system, which means there's a solution, but it's dependent. The first line is dependent on the second line. And what that tells me is actually they are the exact same line. They are not two independent lines. They're dependent on each other. The first line is the same as the second line. Okay? And when that happens, you got to be careful because they're going to have the same slope. So you might think, oh, they're parallel, it's no solution. But actually, if you look real close, they're going to have the same slope and the same y-intercept. They're going to be the exact same equation. In which case, there are infinite many solutions. Okay? There's infinite many solutions because a point here is going to be a solution for both equations. A point here is going to be a solution for both equations. Why? Because they're the same equation.
So they're just right on top of each other.
They are right. They are the same line. Yep, they are the exact same line. And so every point on that line is a solution for both equations because it's the same line. And so if you end up with that, you would then say that this is a consistent, dependent system. And if they ask, well, how many solutions does it have? You would say infinite solutions. Okay? you would use the symbol for infinity. All right, say infinite solutions. So there's our three categories. Do you guys understand how to put the systems into each category? So if a if a system has a solution, now it could have one, could have many, but if it has a solution, what is it? Is it consistent or inconsistent? Consistent. It's consistent. If it has a solution, it's consistent. Okay? And so then if a system does not have a solution, it's inconsistent. So that's the first categories you have to worry about. Now there is a subcategory to consistent systems. It's either going to be independent or dependent. Okay? So if we end up having two distinct lines that will intersect and give us one solution, is it going to be independent or dependent?
Independent.
Independent. How are you going to remember that? I told you one way of how I remember it.
Independent means by itself.
By itself. So what does that mean for the system? How is that going to help you? There's only one solution? Okay. You want to think of it that way. If there's one solution, then it must be independent because it's by itself. That'll work. Okay? Again, I like to think of it as the lines themselves. The lines are independent of each other because this line is different than the other line. Okay? Either way, you need to make it make sense in your brain. Okay? All right. So what we want to do then, now that we have these classifications, and you can go ahead and keep looking at your notes and make sure you use those classifications as we go here. But let's try a few. It says specifically without graphing. Without graphing. Is this system independent, dependent, and then consistent or inconsistent? Okay? So how are we going to tell? What is going to be our deciding factor here? Slope. So we've got to find the slope of these two lines, which means we need to rewrite them in slope-intercept form. So I would take equation number 1. And I need to rewrite it in slope-intercept form by first adding 2x. Now I need to divide by 4. When I divide by 4, I divide everything on the right side by 4. So y equals 2x over 4. 1/2 x. Plus 6 over 4. 3 halves. 3 over 2. Yep. Okay, so the slope is 1/2 there. All right, well, let's take a look at equation number 2. 8y equals 4x minus 12. Well, it looks like all I need to do here is divide by 8. All right, so y equals 4x over 8. So 1/2 x. Don't stop now, though. Don't just go, oh, it's got the same slope. Okay? Because we need to make sure that it's not the exact same line, right? You need to make sure it's not the exact same equation. So what is negative 12/8 reduced down? Negative 3 halves. Is it the same line?
Yes.
No.
If you're saying yes, you need to pay closer attention to what's written. It is not the same line. Please remember, math is very attention to detail oriented. Okay? It looks the same except the y-intercept is in different spots. The first y-intercept is at positive 1.5. The second y-intercept is at negative 1.5. Okay? So they are not the same line, but they do have the same slope. So what does that mean about these lines? These are parallel lines. And so therefore, I heard it already, are they consistent or inconsistent? Inconsistent. These are going to be inconsistent. And then how many solutions does that mean?
No solution.
No solutions.
So you always want us to just write all like.
Just give me all the information. Yep, might as well. That way you just see it over and over and over again. It stick in your brain. All right, questions on this example?
Want me to?
Other example? Oh, for some reason my page does not have the examples. Your page does, so I'll just have to write them down. I can do that. So you guys have examples such as your example A, which says negative 3x plus y equals 4, and x minus 1/3 y equals 1. All right, so looking at that system, we want to decide, are they, well, same thing, consistent, inconsistent, dependent, or independent. So we've got to put them in slope-intercept form. So equation number 1, we have negative 3x plus y equals 4. What do I need to do to put that in slope-intercept form?
Add 3x.
Add 3x to both sides. So y equals 3x plus 4. Let's stop there. Let's not worry about slope or anything yet. Let's just look at equation number 2. Equation number 2 says x minus 1/3 y equals 1. To put this in slope-intercept form, what do I need to do? I need to subtract x. It's a positive x, right? So I got to get rid of it by subtracting it. I now have negative 1/3 y equals negative x plus 1. Okay? Well, now I got to get rid of that negative 1/3 somehow. How am I going to do that?
You switch everything.
Multiply by 3.
Okay, multiplying by, but is multiplying by 3 get rid of the negative?
You would change all the, like, you would switch all of the, like, negatives and positives.
Okay, that's a shortcut, and I agree with you that works. But why are we able to do that?
You divide negative
We are multiplying or dividing by a negative. When you multiply or divide by a negative, it gets rid of the negative out in front and changes everything else. But we also have to get rid of the 1/3, so you guys said we multiply by 3. So let's do it all together by multiplying by a negative 3. Yes? So I'm going to multiply here by a negative 3, multiply here by a negative 3. All right, so then negative 3 times negative 1/3 leaves me with 1y. And on the right side, I have to distribute a negative 3 through. So negative 3 times negative x gives me 3x. And negative 3 times 1, minus 3. All right. Well, looking at our two equations now, are they the exact same equation? No, they're different equations. So we know that they're not going to be infinite solutions. All right. But they are what? They are parallel. They have the exact same slope. So they're parallel lines. And since they're parallel lines, we're going to have no solutions. That means these are inconsistent. Same slope, but different equations. That means they're parallel. Yep. Let's try part B.
So this is just going to be a general rule if they have the same slope on a given parallel.
Make sure it's not the same equation. That's the key. If they're the same equation, then they're going to be dependent. All right, so part B here, we have 2x plus 3y equals 1, and 4x plus y equals negative 3. And we need to go through and, just like always, rewrite these in slope-intercept form. So we're going to go ahead and subtract 2x from both sides. 3y, make it fast, 3y equals negative 2x plus 1. And now I need to divide by 3. So I get y equals negative 2/3 x plus 1/3. Looking at the second equation, 4x plus y equals negative 3. Subtracting 4x gives me y equals negative 4x minus 3. Well, look at their slopes. Are the slopes the same? No, the slopes are not the same. What does that mean?
Intersecting?
They're going to intersect, so we're going to get one solution. And so that means it is consistent. And is it going to be independent or dependent? Yes, independent. These two lines are independent of each other, or independent means alone and it's one solution, so it's by itself. Independent.
So intersecting is different slope, different equation.
Yes. All right. Questions on example B?
So then, the same lines, does that mean the same exact line?
Same. If the same line means same exact everything. It's literally the exact same line. All right, let's try example C here. C says y equals 2x minus 3 and 6x minus 3y equals 9. So taking equation number 1, y equals 2x minus 3, that's already in slope-intercept form, so there's nothing we have to do to that. Let's take a look at equation number 2. We have 6x minus 3y equals 9. I have to subtract 6x. So I get negative 3y equals negative 6x plus 9. I need to divide by a negative 3. So when I do that, I get y equals negative 6x divided by negative 3 gives me what? No. No.
3x.
No. 2x.
Oh, I thought you were done.
Negative 6x divided by a negative 3 gives me 2x. Positive 9 divided by a negative 3
It's negative 3.
is negative 3. So, here we go, looking at these two equations now. Hey, look, they happen to have the same slope. They must be parallel, huh?
The same equation.
They're the exact same equation. Not only are they parallel, they're the exact same equation. And so since they're the same equation, these are going to be the same line. That means they're going to have infinite solutions. And it's going to be consistent and dependent.